continuing with our SAT practice, again, I recommend that you um, attempt the problems by pausing the video and then listen to the solution. So give this problem a shot. All right, so which of the following numbers is not a solution to the inequality 3x minus 5 is greater than or equal to 4x minus 3? So there are two pretty good ways to address this. One way is to just directly attack this inequality. So I will first get all the x's on one side, and I'm going to move the positive 3x because it is less than 4x, and that will leave me with a positive number of x's, so I don't need to worry about dividing by a negative number and flipping the inequality. And then I will add 3 to both sides, and I will see that negative 2 is greater than or equal to x, or as a lot of people would prefer to see, x is less than or equal to negative 2. So these are the x values that will solve this inequality. And so I want to figure out which is not a solution. The only one of these that is not less than negative 2 is negative 1. As a quick reminder, if I have 0 here, negative 1, negative 2, negative 3, you can see that negative 1 is to the right, less than would be the left. Another possibility, another way to deal with this is just by checking each of these in this inequality. So I could just plug in the negative 1 and see that this value would give me negative 3 minus 5 is negative 8. I could plug the negative 1 in here. Negative 4 minus 3 is negative 7, and I can see that because we're dealing with negatives, this is not true. Negative 8 is actually less than negative 7. I could check the other ones. I'll put in the negative 5 just to show you what I mean. So if I put in the negative 5, I put 3 times negative 5 minus 5. 3 times negative 5 is negative 15. Minus 5 is negative 20. And I could put the negative 5 in there. So 4 times negative 5 minus 3. 4 times negative 5 is negative 20. Minus 3 is negative 23. And it is true that negative 20 is bigger than or equal to negative 23. So that's why it's like this is not the answer. Okay, give this problem a shot. All right, so we have a bar graph here. That deals with the number of apples as compared to the number of seeds in that apple, and we have a total of 12 apples. So based on the histogram above, of the following, which is closest to the average, the arithmetic mean, number of seeds per apple? So two ways to address this. The best way is probably with a weighted average, saying, okay, I have 2 apples with 3 seeds apiece. I have 0, I'll put that in here, so I have 0 apples with 4 seeds apiece. I have 4 apples with 5 seeds apiece. I have 1 apple with 6 seeds. I have 2 apples with 7 seeds. I have, continue that, 0 apples with 8 seeds, and I have 3 apples with 9 seeds. I could do this in a calculator, I could do this by hand. I'm going to work it out by hand because it's not going to be super easy with this calculator, but with a graphing calculator it wouldn't be too bad. So 2 times 3 is 6, 0 times 4 is 0, 4 times 5 is 20, 1 times 6 is 6, 2 times 7 is 14, 0 times 8 is 0, 3 times 9 is 27, add these together, get 20, add that on, get 40, and then I have, let's see, 67, plus 6 more gives me 73. And the final bit is to try to determine which is closest to the arithmetic mean. And if you remember, the arithmetic mean is the sum divided by the quantity. We knew that we had 12 apples. Their sum was 73, so that would give me the mean is 73 over 12. I will jump to the calculator for that, even though I could get a good estimate in my head very quickly. And I get a little bit over 6, so there's my answer. Now, that's the best way. I'm not going to write out not the best way, but if you understand this graph, you could also have done, there are 2 3s, so I'd have 3 plus 3. There are 4 5, so plus 5, plus 5, plus 5, plus 5. And I'll put a little dot, 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 all the way up to 3 9s. So I could actually, in my calculator, just type in all of these add together. I'll get 73 divided by 12, get my mean. Give this problem a shot. Okay, so we have a chart here that relates the gender of students with the course they're in, and it's like they're 10th grade students. So a group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Fun note, data is plural, so we have the plural verb. Datum is singular, but that's a little side note. Which of the following categories accounts for approximately 19% of all the survey respondents? So we want to find pretty much what is 19% of 310. So this is the sort of best way to attack that. And I could just say, okay, 19% of 310, I can either do 0.19 times 310, or I could do the proportion. So 19% is 19 over 100 equals something out of 310. Either way, cross multiply and solve, or just multiply straight through, and I'll do this in the calculator. So clear this off. 0.19 multiplied by 310 gives me about 59, and both will give me the same, so I'll write 58.9. And so this is the best way to do it, sort of calculating directly what we want, and then looking at the chart and saying, okay, do I see something close to 58.9? And there I have it. So I'm going to look for something that's talking about the number of males in geometry. So let's see, males taking geometry, there we go. A not quite so good way, but also feasible, would just be to find each individual probability. So I'll do the first one so you can see. If I want to find the probability of students who are female in Algebra 1, I could do 35 divided by 310. Again, we're saying out of all respondents. That's why I'm using this as opposed to any of these other totals. I'll go to my calculator. And let's try 35 divided by 310. And that would give me 0.1129, which is about 11.3%. And I know that that's not what I'm looking for, so I go on. And so I could do that for each one of these, but you can notice that, okay, instead of just doing one set of calculations getting an answer, now I'm doing 6 sets. Okay, give this problem a shot. All right, so we have another table, or I guess this is not so much a table, it's just a list put into a grid. So we have a list of the lengths of fish in inches. Someone's apparently been doing a lot of fishing. Let's see, we have 7 per row, 3 rows, gives me 21 fish. Okay, the table above lists the length to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range values listed above, which will change the most if the 24-inch measurement is removed from the data? Okay, so quick rundown. Mean is, of course, the sum divided by the quantity. The median is the middle value. And the range is highest minus lowest. Now, the nice thing, so a lot of times we will use median in the real world to measure things like salary or household income because the median takes out all of the small values, all of the high values. I don't want one very large fish to be able to skew me into thinking that every fish is big, or conversely, as a conversely, no, I guess inversely, one very small fish, leading me to believe that that everything is smaller. The median doesn't really care about the specific values out here at the ends. It just goes to the middle. And so let's see, halfway through 21 will be the 11th fish, because the 11th fish has 10 fish before the beginning and 10 fish after that. So I count in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice they are already in increasing order, so I don't need to worry about that. And so the median was 12. If I were to knock off this, now my median would be stuck between these two, and it would still be 12. So the median didn't change at all. And most of the time, if I knock off outliers, the median won't change much. That's why we like the median. Okay, the mean. Now, the mean, basically, we add up everything and then divide by the quantity. Now, if I look at this mean, the 24 is bigger than everything else. But keep in mind that I'm going to have something, so I'll call this blank plus 24, all divided by the 21 measurements in here. And so if I were to get rid of the mean, I'm not going to add them up and do the change. You could. But if I were to get rid of the mean, really this 24 is going to be divided by 21. And then added on to the rest. And so actually it's going to make a very small change in total. And the change is even less because I'm really not comparing this to that over 20, I'm really comparing it to that over 20. And so the actual previous mean is somewhere near 12. So really my change is much smaller. Again, you can find the two means if you desperately want to, but you probably wouldn't have time to do 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 16 plus 24 divided by 21, then do the same thing plus 16 divided by 20. But the actual change is going to be much closer to 0.5, basically because this large number is split up amongst the 20 other values. However, for the range, that doesn't happen. The range, the fact that this is 8 larger than the next largest value is all there. And so the range to begin with, would have been 24 minus 8, which is 16. Okay, 24 minus 8. But if I drop the outlier, it's going to be 16 minus 8, which is just 8. And you can see a massive change compared to a median that's not changing, and a mean that for some possibly confusing reason is changing at least less than 1. So, which will change the most if the 24-inch measure is removed will be the range. And in most cases, there can be special cases, but in most cases, the range will change the most if I drop off a big number or a small number, because now it is the entire difference here is all accounted for in the range. Okay, give this problem a shot. So we have a graph. We have this is a graph for the total cost of renting a boat by the hour. Y, or the dependent variable, is the total cost in dollars. The independent variable is time in hours. And we want to know, what does the c-intercept represent in the graph? Now, this is the correct way to state it, because this is the c-axis, this is the h-axis. But let's keep in mind what we're dealing with. So if I had y equals mx plus b, the y would be over here. The x would be over there, and this would be the y-intercept, which I would find right here. So similarly, for the c-intercept, that's not really legible. Let me go to this. For the c-intercept, I'm looking at the same thing. And so I have this point, 0, 5. And just keeping in mind, this is the time. This is the cost. So basically what it's saying is, if I rent the boat for 0 hours, so 0 hours will give me a cost of $5. And let's see which one of these represents that. So the initial cost of renting the boat, the cost to start off with before I've had it for any hours. So that looks good. I'll circle that, but let's check the other ones to make sure. The total number of boats rented, well, this is pretty much renting one boat. That makes no sense. The total number of hours the boat is rented, well, the hours is 0. We're not dealing with some number of hours. This is just one space and time, so that doesn't make sense. And the increase in cost to rent the boat for each additional hour. So if I look at this, from at 0, I have $5. At 1, I have 8, and it keeps going. At 2, I have 11. I can see that I'm actually increasing by $3 per hour, and that's because that's the slope, up 3 units over 1. Noticing that this step here is 1, even though I see 4 boxes. So A is the only one that makes sense. All right, I hope that helped out, and we'll get back to some more of this tomorrow.